Dear students, in this video, I am going to teach one theorem in complex analysis. The statement of the theorem is any bilinear transformations preserves cross ratio. Okay, so any bilinear transformations preserves cross ratio. So we have to prove this theorem. Any bilinear transformations preserves cross ratio. We have to know what is bilinear transformation and cross ratio. Okay, so first we have to define bilinear transformation and cross ratio. Okay, so what is bilinear transformation? The function w is equal to az plus b divided by cz plus d, where a, b, c, d are constants. So then the w is known as the bilinear transformation. Okay, so the bilinear transformation can be defined as what? The w is equal to az plus b divided by cz plus d. And the cross ratio, okay, so the cross ratio can be defined by, so let z1, z2, z3, z4 are 4 points in the complex plane. Then the cross ratio is defined as is z1, z2, z3, z4 is equal to z1 minus z3 into z2 minus z4 divided by z1 minus z4 into z2 minus z3. Okay, so here if you want to prove that the bilinear transformation is preserves the cross ratio means the W, it is possible to write in terms of Z. That means some W1, W2, W3, W4 is equal to Z1, Z2, Z3, Z4. That is we need to prove here. Okay. So the proof is let Z1, Z2, Z3, Z4 are the points in the complex plane. So then by the definition of cross ratio, we have to write Z1, Z2, Z3, Z4 is equal to Z1 minus Z3, Z2 minus Z4 and divided by Z1 minus Z4 into Z2 minus Z3. So it is easy to remember, right? So Z1 minus Z3 and Z2 minus Z4 and Z divided by Z2 minus Z3 into Z2 minus Z1 minus Z4. Okay, so consider this is 1. And now we have to define W1 and W2, W3, W4 in the complex plane, which is equal to W1 minus W3 into W2 minus W4 divided by W1 minus W4 into W2 minus W3. So consider this is 2. So from the definition of the bilinear transformation, we have W I is equal to A is at I plus B divided by C is at I plus D. Okay, so by the definition. So now we have to find W1 minus W3, W2 minus W4, W1 minus W4, W2 minus W3 by using this definition. Okay, so what is W1 minus W3? W1 minus W3 is equal to, so replace I is equal to 1, we get what? A is Z1 plus B divided by C is Z1 plus D. Okay, so replace I is equal to 3, we get A Z3 plus B divided by C is Z3 plus D. So which gives W1 minus W3 is equal to A Z1 plus B divided by C Z1 plus D minus A Z3 plus B divided by C Z3 plus D. So now we have to find the LCM. We get A Z1 plus B into C Z2 plus A Z1 plus B into C Z3 plus D minus A Z3 plus B into C Z1 plus D divided by C Z1 plus D into C Z3 plus D. So now we can expand this. We get AC Z1 Z3 plus AD Z1 plus BC Z3 plus BD minus AC Z1 Z3 minus AD Z3 minus BC Z1 minus BD divided by CZ1 plus D into CZ3 plus D. So here AC Z1 Z3 minus AC Z1 Z3 cancel and BD minus BD cancel. In the next step, so we have to take AD as a common and minus BC common. We get AD into Z1 minus Z3 minus BC into Z1 minus Z3 divided by CZ1 plus D into CZ3 plus D. So which is equal to Z1 minus Z3 into AD minus BC divided by CZ1 plus D into CZ3 plus D. Okay, so which implies W1 minus W3 which is equal to K1 into Z1 minus Z3. So here K1 is equal to AD minus BC divided by CZ1 plus D into CZ3 plus D. Okay, so similarly we have to find W2 minus W4. So W2 minus W4 is equal to K2 into Z2 minus Z4. Okay, so now W1 minus W3 into W2 minus W4. So which is the numerator of equation 2. Okay, which is equal to, so K1 into K2 into Z1 minus Z3 into Z2 minus Z4. So K1 is a constant, K2 is constant. So again we get some constant. Therefore consider K1 into K2 is some K. So K into Z1 minus Z3 into Z2 minus Z4. So which implies W1 minus W4 is equal to K1 into Z1 minus Z4 and W2 minus W3 is equal to K2 into Z2 minus Z4, which gives what? K into Z1 minus Z4 into Z2 minus Z3. So now we have to replace all these four values, okay, in equation number 2. This is the W1 minus W3, W2 minus W4 and W1 minus W4, W2 minus W3 into, we get W1 minus W3 into W2 minus W4 divided by W1 minus W4 into W2 minus W3 is equal to K into Z1 minus Z3 into Z2 minus Z4 divided by K into Z1 minus Z4, Z2 minus Z3. K and K cancel. So we get W1 minus W3 into W2 minus W4 divided by W1 minus W4 into W2 minus W3, which is equal to Z1 minus Z3 into Z2 minus Z4 divided by Z1 minus Z4 into Z2 minus Z3. So which is equal to what? W1 comma W2 comma W3 comma W4, which is equal to Z1 comma Z2 comma Z3 comma Z4. So hence the bilinear transformation preserves cross ratio. Okay, so which completes the proof of the theorem. So from this we have to conclude that the bilinear transformation preserves the cross ratio. Thank you.